Okay, so welcome to Maths with E Show. Today I'll be talking about the identity matrix and the inverse matrix. Now, I think the best way I can explain to you what an identity matrix is to go back to our knowledge of arithmetic, especially the basic operations such as multiplication and addition. Now, from there, we can now see how we can relate that to matrix. Okay. So we know that in arithmetic that an identity is that particular number in which, when being operated with another number, doesn't really change that number. For example, we know that in multiplication that 1 is an identity because 2 times 1 still gives you 2. 4 times 1 still gives you 4. 100 times 1 still gives you what? 100. 1 is an identity in multiplication because when operated on any number does not really affect the value of that number. Okay. Now, likewise in addition and subtraction, 0 is an identity because if we go 2 plus 0 still gives 2, 4 plus 0 still gives 2, 100 plus 0 still gives what? 4 plus 0 still gives 4, 100 plus 0 still gives 100. So 0 is also an identity under addition and subtraction, okay? Because even if it's still subtraction, it still gives us the same value. So 0 is an identity because its effect on these numbers does not cause any change. Okay, so this same idea is what we are going to use in identity matrix. So an identity matrix is that matrix that when used to multiply another matrix does not really change the value of that matrix still remains the same. So for example, if A is a matrix A, B, C, D, then an identity matrix which is denoted as I must multiply this A to give us the same matrix. So which means that if A is matrix A, B, C, D, and it's multiplying another matrix, let me say E, F, G, H, and you are getting A, B, C, D. You are still getting A, B, C, D. It therefore means that this E, F, G, H must be an identity matrix. It must be an identity matrix. Okay, so let's just get this idea. Now, the question is, how do we know an identity matrix? Now, an identity matrix, often denoted as the symbol I, is always a diagonal matrix in this form. A diagonal matrix is a matrix that the principal diagonal or the major diagonal has 1 at the major diagonals. Yeah, so because the major diagonal or the principal diagonal has 1 or 2, that is why it is also called a unit matrix. Okay, so even if it is a 3 by 3 matrix, the major diagonal must all be 1. Okay, so for a 3 by 3 matrix, this is how an identity matrix look like. Okay, so just take note that anytime any matrix multiplies a unit matrix like this, it doesn't change the value of that. and the multiplication of identity matrix is always commutative, okay, unlike others. So it means that if is a matrix, multiplying another matrix, which is an identity matrix, okay, is to still give you the same value as the identity matrix multiplying the particular matrix. So let's stop here for now, and then do have a good day. Bye.